The final talk of the day is by Kris and is about building without the public internet.
Hello, so I'm Kris. I'm a software engineer at Salesforce, and today I'm going to be talking about how we build without using the public internet. So I'm going to start off by giving a little bit of background. So our team primarily used to be focused on building microservice libraries, and then in 2017, we decided it was a good idea to also bring the clients of those libraries into a big monorepo where our libraries are built. So we have two shared repositories, one Java and one Golang. We're currently using Bazel 5, although I think this week, hopefully we're going to be on Bazel 6, and it sounds like we might need to start using Bazel mod soon as well. So we have various CI jobs that do different things. They build, test, and publish artifacts to different places, like our container images to our registry, and we also run validations like security scans. So a little bit about our team. This was us at BazelCon last year. Peter and Simon have given various talks at BazelCon before, for the first time in 2018, I believe. And it's great to be back at BazelCon this year, and this is my first time speaking at a conference, so thanks for listening. So now, what is this talk about? So we want our Bazel builds to work without needing to reach out to the public internet for any build dependencies. We already use internal mirrors for our Java and Golang dependencies, so this is about all of the other things that Bazel needs to pull during builds. This includes rule sets like rules OCI, but also all the transitive dependencies of those rule sets. So why do we want to do this? There's two reasons. The first is security. I care a lot about security, and that's why I have a very scary guard dog. He's very scary, right? So Bazel already has a lot of good security features built in, like checksum verification, and these features do reduce a lot of risk, but ultimately some of our builds did not reach out to the public internet at all, so this is why we want to do this. The second reason is reliability. If we're downloading a dependency from the public internet and the owner of that stops serving it, we don't want our builds to fail. So speaking about reliability for a minute, I think this came up earlier as well. So we obviously weren't the only people affected. In January of this year, there was an incident where the checksums of existing GitHub archives changed, and this caused a major issue for our builds because the checksum of our downloads didn't match what the workspace file expected. So given all of this, how do we actually achieve builds without the internet? So we started off with an initial attempt, and looking back, this was a little bit naive and wasn't perfect. So we built an artifact that included all build dependencies, and we baked this artifact into our CI image. And during CI builds, we extracted this artifact into a directory and pointed distdir to it. If you don't know what distdir is, it's basically a flag that you can use where Bazel will check for dependencies in a directory before it fetches them from the internet. So we soon realized that this solution didn't scale very well because anytime we updated or added a new build dependency, we needed to rebuild the CI build image and the artifact. So moving on to our current solution, it still isn't perfect, but it works well for us. So it's basically a semi-automated mirroring solution that uses some useful Bazel features. We start off by cataloging our build dependencies. Then we parse the catalog and perform some actions for each entry. Then we verify, and finally, we handle some edge cases. So starting off with how we catalog. So the Bazel sync command generates a snapshot of all repositories mentioned in the workspace. We have an optimized Bazel sync command that will comment out things that we don't care about. For example, OCI pulls, because we already know that our images are coming from a private Docker registry. So this is the output of the resolve BZL. And from the URL section, sorry, we're able to tell if a dependency is already mirrored or if we need to mirror this dependency. So next, we parse the catalog and perform some actions. So we have some custom scripting that parses the catalog and performs some actions. So it identifies files that haven't been mirrored yet, it downloads them and uploads them to our internal blob storage, and then we generate a new workspace include file that contains the mirrored URLs of the transitive. So we load this BZL file first, because it's important that this is loaded before any of the other rules. So you can see here in the workspace include file, we add the mirror path URL as well. So then we need to verify that everything is mirrored and working. So we have an extra full build and CI job that blocks access to the public internet, and it does this using the experimental downloader config. We utilize this flag a lot for different reasons, and this is just one of them. So this is our downloader config. It starts off by blocking access to everything, and then one by one, we allow access to our internal resources. So finally, we need to handle the edge cases. So there's some things that don't seem to work very well with this approach. So we find these out from the verify step because this CI job fails because it can't find any URLs that aren't blocked. So we're able to then handle these edge cases, again, using the Bazel downloader config, and we just rewrite those URLs. Thank you. And just to mention, we have a few open source projects that we work on. So if you're interested in any of them, please check them out.